Hello and welcome to our video on how solar inverters work. As our world leans more towards renewable energy, solar power is no longer just a shimmering dream, it's a reality for many homes and businesses. At the heart of this transformation, the humble solar inverter quietly works its magic, turning sunlight into usable electricity. But what's really happening inside that nondescript box? How does it take the direct current or DC electricity from solar panels and transform it into the alternating current or AC electricity that powers our lives? Today, we're peeling back the layers to reveal the inner workings of a solar inverter, the unsung hero of solar power. We'll delve into the essential electronic components that make it tick and how they work together to harness the power of the sun. So, if you've ever wondered about the science behind the solar revolution, you're in the right place. Ready to dive into the world of solar inverters? Let's begin. To understand the working of a solar inverter, we need to first look at the main electronic components used in it. These components, each with a unique role, come together to form a functional solar inverter that enables us to harness the power of the sun. The first key component is the MOSFET, or metal oxide semiconductor field effect transistor. MOSFETs act like gatekeepers, switching the direct current, or DC electricity, from the solar panels on and off at extremely high speeds. This rapid switching is a crucial part of the conversion process from DC to alternating current, or AC electricity. Next, we have transistors. These little devices are the amplifiers and controllers of the electrical signals within the inverter. They help maintain a stable output voltage, ensuring that the electricity we use in our homes and businesses is reliable and steady. Another important player in our solar inverter is the IGBT, short for insulated gate bipolar transistor. This component is responsible for handling high power and voltage levels. IGBTs convert DC into AC by rapidly switching the current on and off multiple times per cycle. The solar inverter also incorporates a component known as an mppt or PWM-IC, standing for Maximum Power Point Tracking or Pulse Width Modulation Integrated Circuit. This component is like the brain of the operation, optimizing the power output from the solar panels by constantly adjusting the voltage to achieve maximum power. Apart from these, a solar inverter also features a step-up transformer. This device elevates the low-voltage DC from the solar panels to a higher voltage AC, necessary for use in households and industries. Another crucial component is the rectifier. This element converts the AC voltage from the transformer into a stable DC voltage. This stable DC voltage is then used to either charge the batteries or directly power the appliances. Lastly, we have the batteries. These are the storage units for the excess energy produced by the solar panels. The energy stored in these batteries can be used during periods of low sunlight or when the demand for electricity exceeds the capacity of the solar panels. These components, each with their unique roles, work in harmony within the solar inverter. They ensure that the energy harnessed from the sun is converted into a form that we can use in our everyday lives, contributing towards a sustainable future. Now that we've acquainted ourselves with the components, let's see how they interact and convert sunlight into electricity. The process begins with the solar panels on your rooftop. These panels are made of photovoltaic cells which are designed to absorb sunlight. As they soak up the sun, these cells generate direct current or DC electricity. However, most of our homes and appliances run on alternating current or AC electricity. This is where our trusty solar inverter steps in. The DC electricity from the solar panels is first fed into the inverter. Here, it encounters the MOSFETs, which act as rapid on-off switches. They flicker on and off at high speeds, allowing the electricity to flow in pulses. This is the first step in converting the steady DC current into an alternating one. The electricity then passes through transistors. These crucial components amplify the pulse signals and control the flow of electricity within the inverter. They work to ensure that the output voltage remains steady, so your appliances receive a constant, reliable source of power. Next up, the electricity meets the IGBTs. These components handle high power and voltage levels, making them perfect for the task of converting DC electricity into AC. They do this by switching the current on and off multiple times per cycle, effectively changing the direction of the electrical flow, the very essence of alternating current. While all this is happening, the solar inverter's mppt or PWM-IC is working behind the scenes. This smart piece of technology constantly monitors the power output from the solar panels and adjusts the voltage as necessary. Its goal is to ensure the solar panels are always operating at their maximum power point, squeezing every last drop of power from the sunlight they capture. Once the electricity has been converted into AC, it's not quite ready for use just yet. It's still at a low voltage, so it needs a boost. This is where the step-up transformer comes in. As its name suggests, this component steps up the voltage of the AC electricity, preparing it to be used in your home or business. But we're not done yet. This boosted AC electricity then flows through the rectifier. Here, it's converted back into a stable DC voltage. This may seem counterintuitive, but it's an essential step for two reasons. Firstly, it's safer to store electricity as DC, and secondly, some appliances and devices in your home may actually run on DC. The freshly rectified DC electricity is then either used immediately to power your appliances, or it's stored in the inverter's batteries for later use. These batteries come into play when the sun isn't shining, ensuring that your home or business has a steady supply of electricity 24/7. So, to recap, the working process of a solar inverter is a symphony of components working together. Sunlight is captured by solar panels and converted into DC electricity. This DC electricity is then switched, amplified, and transformed by the MOSFETs, transistors, IGBTs, and step-up transformer into high-voltage AC electricity. The mppt or PWM-IC ensures the maximum power output from the solar panels, while the rectifier converts the AC electricity back into a stable DC voltage. Finally, the batteries store any excess energy for later use. And that, in a nutshell, is how a small box converts solar energy into usable electricity. Let's recap everything we've learned today. We've journeyed deep into the heart of a solar inverter, discovering how this remarkable device converts sunlight into usable electricity. The solar inverter, a key component in the renewable energy landscape, plays a crucial role in transforming the direct current, or DC, electricity generated by solar panels into alternating current, or AC electricity, which powers our homes and industries. We've explored the vital electronic components that make this possible. First and foremost, the MOSFET, a component that switches the DC electricity on and off at high speeds. Then the transistors, which amplify electrical signals and control the flow of electricity, ensuring a stable output voltage. We also learned about the IGBT, a component designed to handle high power and voltage levels, playing a critical role in converting DC electricity into AC by switching the current on and off numerous times per cycle. And let's not forget the mppt or PWM-IC, which optimizes the power output from the solar panels by continuously adjusting the voltage to achieve maximum power. We also discussed the step-up transformer, which converts low-voltage DC into higher-voltage AC, and the rectifier, which stabilizes the AC voltage into DC, charging the batteries or powering appliances directly. Lastly, we touched on the role of batteries in storing the excess energy generated by the solar panels, providing power when sunlight is unavailable or when electricity demand exceeds the solar panel's output. Together, these components work in harmony to convert solar energy into AC electricity, optimizing output and storing energy for later use, making solar inverters an integral part of our renewable energy future. Thanks for joining us today. We hope you've learned something new about how solar inverters work. Stay tuned for more enlightening videos on solar power and other renewable energy topics.